Alrighty, so I had a friend ask me a question about how to use hash maps in Java. So I'm going to go ahead and give an analogy between hash maps and arrays, or should I say array lists in Java tonight. I'm going to be using Java 8. Java 11 just came out, but there's no reason we're using anything specific to that, as we're not doing anything with lambdas or local variable syntax. So just to keep things simple, since a lot of people will already have Java 8 installed if they're a at-home hobbyist developer, maybe they have Java 11, it is backward source compatible. I'm just going to start out with a simple class here that has a very simple structure with test class, I called it, and a main function. So inside of here, we're going to write out the declaration ArrayList string sum list equals new ArrayList string. And I'm going to alt enter to import the class in here. I'm going to do the same thing with HashMap string sum map equals new HashMap string. Once again, I'm going to alt enter to import. Now, the first thing you might notice here, the list has one argument in the brackets. The hash map has two. An array list is just holding a string or an integer or any user-defined object that you like inside of it. A hash map, on the other hand, is a little more like a dictionary. It has a key and a definition. Typically you call it a key value pair, but to give the dictionary analogy, I'm just going to call it a definition. So first thing we'll notice here when we're looking at our syntax, this is grayed out. The explicit type can be replaced with empty. One thing Java 7 gave us, actually let's go back a bit further, Java 5 gave us was the diamond syntax of generics, that we could do generic typing, which is common to most languages, is taken as a given. When I started coding, it was Java 2, Java 1.2, and we didn't have any of that. Now we have these generics. But in Java 7, we were given the opportunity now to use the diamond syntax without having to explicitly redeclare the typing again, which is once again where we're looking now with Java 11 to be able to use the variable type inference. But to keep things simple, we're just going to use Java 8 semantics here, and we see that's cleaned up now, redundancy gone. With an array list, the way we would put in something into the array list, we'd go sum list dot add, and it tells us that it's going to be Boolean. So what does Boolean mean in this case? Well, it's going to tell us was it added or not. There's also an add to a specific index, the element. There's also add all, where you can add a collection or add it to a specific index. For our purposes, we're just going to stick with a simple add. We're going to go hello. And then here in the hash map, we're going to do sum map dot, and we don't have an add here. What we have is a put. And the put method has one use case, the key and the value. You could also stick another map inside the map. But since this is an unordered hash map, it means we're hashing the keys. This generally will give you a very good lookup time. So let's just start with this here and go key and then hello. So in this case, nothing is really going to be much faster than there. There's only one element in each, but we're just going to put this out into some print line statements. For string s in sum list, we're just going to go print s. This is again kind of overkill since we only have one item, but what we're going to do is do this just to illustrate how it would work in the generic case. So in the case of the hash map, we can then go sum map dot key set, and then system out print line s dot get s dot, yeah, probably just s. Never really think about these things, but if we compile this, we see hello and key, which is not what we want. So that was showing us the keys themselves. But if we want to get the values, then we go values. Now we're going to get the value. If we want to do this explicitly, we could go system out print line some map dot get key, and now it'll show again hello. And if we were to add a couple more entries to this, some list dot add how are ya, we're to go some map dot put key how are ya. Now you might say to yourself, that doesn't make much sense now, does it? When we run this now, it's how are ya, how are ya, how are ya. So it's going to put in the first two from the string, the array list, and then the one from the map. What happened to our first one? Well, if we go into here and we walk into the decompiler, we can see the put key with which it's to be associated, value to be associated. If there was no mapping for key, return can also indicate previously associated with key. That doesn't tell us much, but what I'm going to say here is associates with the map. The map previously contained a mapping, the old value is replaced. So it just overwrote our map, so there's no error. Keep that in mind. If we were to do this now, the original map at the bottom here is going to say hello. It's going to go hello, how are ya, in this one. Hello, how are ya? Then it goes how are ya, question mark here, because that's the key to. And then it's going to go ahead and do the key again. Note that it went how are ya, hello, instead of hello, how are ya. The order was backwards. I'm going to make this a little bit simpler to read here, so I'm just going to go system.out.println ArrayList string. I'm just going to paste this down here, and I'm going to put in the HashMap string. That way we can just verify there's not some funkiness going on here to convince you that that's what loop it's in. And so we see here that the strings are how are you and hello. But if we were to say get rid of this string array, let's take another look at this whole map thing. Let's just get rid of all these comments, all these extra lines, and we're just going to go ahead and focus exclusively on the hash map. Let's put a third key in. Now, based on this, we might think it's going to go, what's up, how are you, hello. Let's find out. Wait a second, that doesn't make sense. It just came out differently yet. The reason for this is a hash map is an unordered map. That said, if we did a linked hash map, and we run this again, hello, how are you, what's up? Now we've created a hash map with a linked list inside of it. So the first one has a pointer to the second key, to the third key, and so on and so forth. The downside of a linked hash map is that you're losing performance in the sense that a hash map, as I was saying at the beginning, has a big O of 1 value equals a hash map. Let's go ahead and put this as a comment. And that the worst case for a linked list is going to be an O of n value, because you would have to look at every single element in the worst case to find it if it was the last element of the list. Whereas you have an O of 1 with a hash map, because given a key, there's guaranteed to be a value. So worst case, you look one time. When you mix the two, it gets a little more murky, because then you might have to look all the way to the end, but you might be able to look at the beginning too. So the fun thing about hash maps is you can insert an array list inside of a hash map. So let's go ahead and change this from string to ArrayList of string. And let's go this list, some list right here, uncomment this out. Now if we were to go ahead and create a secondary list, let's just call this 2 and 2 and 2, and make this like so. And then let's go here and go new array list. That didn't throw an error. Fancy that. Now instead of for string s, now we're going to have to go in here and do a little more magic. So for array list string s in some map.values, then for string stir in s, then we can do this now. Let's just change that out to list and s. That way it's cleaner and we don't have to change the code everywhere. There. Now if we do this, now you notice we have to do a unfortunate O of n squared algorithm for the above list. The reason why we have to iterate each of these items, and then inside of each item you have to iterate all the internal items again. Very, very bad, but it's very common in practice to have to use a user-defined value or a complex type inside of a hash map. So now you're constrained by the speed of the internal data structure, but at the same time you can take advantage of the hash map's easy lookups. But if we print this out, hello, how are you? Hello too, how are you too? But the third one never iterated. So what we can do to verify that it did iterate, int I equals 0, system.out.println I is plus I, and then at the end of this list we do an I++, then we can see if it's actually hitting the third item. I is 0, I is 1, I is 2. So it's actually going ahead and looping over these, then looping over these, which we would expect. You might think that it would loop this item and then do the print lines, but it's optimizing for us. So the thing is it does read the third one, there's just nothing inside of it. So what we could do here is we could go summap.get key3.add new item added. Now if we run this again, then we get new item added to the third list. But now what we see is that I is 1, I is 2, and again the multi-threading involved, where the code optimized things, has made it to where it's picking it in a different order again. But yeah, there's your basics of how you would work with hash maps and lists, and why they're different and why they can interchange with each other, and hopefully that'll spur some new questions. And if you have questions, drop them in the comments and I'm more than happy to answer or make a new video to explain it. I realize this was a lot to digest, but that was sort of the point, was just to kind of give a real survey and go a little into the weeds and experiment. Thank you.